Hello, ladies and gentlemen, Root Beer here with our very last question from the Grade 8 Gauss paper from 2009. Let's take a look at this question here. Question number 25. A list of 6 positive integers, p, q, r, s, t, u, satisfies p is less than q is less than r, okay, all the way up to u. Okay, so they're ordered. They're ordered, p is the smallest, u is the biggest. There are exactly 15 pairs of numbers that can be formed by choosing 2 different numbers from the list. The sums of these 15 pairs of numbers are, and it's very nice, they've ordered them for us, so 25 is the smallest, all the way up to 117, and there's lots of different numbers in between. And we're being asked which sum equals r plus s. Okay. R plus s. Now, why would they ask r plus s? Well, R and S are right in the middle. So they're actually going to be pretty difficult to work out. Imagine if they had asked us a different question. What if they'd asked us, what's the sum of P and Q? Well, P and Q are the smallest 2 numbers, right? So P and Q should add up to the smallest number that we've got, 25. Because imagine that 2 other numbers added up to something small, or added up to 25. Then P and Q wouldn't give us the biggest sum, but they're the 2 smallest numbers. They should give us the smallest sum. Okay? And, you could prove this with inequalities, but it doesn't matter. It's fairly intuitive, I would say. The smallest numbers will add up to the smallest number. And in fact, the biggest numbers will add up to the biggest number. So choosing R and S in the middle, well, we've got a long way to go. And you might say, well, R and S, they're the middle numbers. Let's pick the middle number here, 63. I'm inclined to believe that that is not going to be the right answer. Okay? Just because, well, they know when they make up these contests that some people do guess. And, while that seems perfectly sound reasoning, the smallest numbers add up to the smallest number, the biggest numbers add up to the biggest number, so the middle number should add up to the middle number. That isn't necessarily how it's going to work out. And you should be more confident in your answer than, well, I recognized a pattern. Okay, that's not good math. That's good for making a hypothesis, making a guess. I think this should be it. But math is a bit more exact. Math is a bit more sure of itself. You should be able to say, R plus S is definitely this. Here are my calculations, or here's my logic, or here's my algorithm, something like that. Okay? So we've got a little bit more work to do here. Okay, but I think we can all be pretty confident that P plus Q being the smallest numbers, there's no way that they could add up to anything but the smallest. And T plus U, they're the biggest numbers, they're going to have to add up to the biggest. But, then there's a bit of a mix match. Now, the numbers that are represented are all the various sums. So P plus Q, P plus R, P plus S, P plus T, P plus U, and then we start with Q, so Q plus R. We already did Q plus P, by the way. Q plus S, Q plus T, Q plus U, and you can keep going. And you will get 15 sums here. I think I'll try and write them all out as I continue talking. Okay, so there's 3, you'll get 3 more. S plus T, S plus U, and finally T plus U. Now the problem is we don't know which numbers, which sums correspond to which numbers, although we do know T plus U should be 117 and P plus Q is 25. Okay? Just, really quickly in case you want to say, well, how do you know P plus Q should be the smallest? Well, suppose another one, like, I don't know, Q plus S was 25. But P is less than S. They tell us that in the question. So if I add a smaller number onto P, I should get a smaller sum. But there isn't a smaller sum than 25. So that's how that works. Okay. Now, what can we do? Well, you may not have seen this. It entirely depends on how many contests you've done. Okay. If you've seen a lot of contests, you probably didn't have a big problem with this one. But this is sort of a common scenario. You have a bunch of unknown numbers, and they're all added up in pairs or added up in triples, so that every possible pair or every possible triple or every possible quadruple of numbers is represented exactly once. Okay? And this is pretty powerful, because watch what happens. I don't know what exactly, what a p plus s is. But look, if I add up all these numbers, I'll get p plus q plus p plus r plus p plus s plus p plus t plus p plus u. But look how many p's I'm going to get. I will get 1, 2, 3, 4, 5 p's. Look how many q's I will get in my sum. 1, 2, 3, 4, 5. Look how many r's I'll get. 1, 2, 3, 4, 5. Look how many s's. 1, 2, 3, 4, 5. Look how many t's I'll get. 1, 2, 3, 4, 5. Look how many u's I'll get. 1, 2, 3, 4, and 5. Okay? This is a very, very common thing. Imagine if I had just A, B, and C, and I added them up in all different possible ways. It's very easy to see, oh, if you add them up, I'll get 2 A's, 2 B's, and 2 C's. Okay? If I had 4 numbers, A's, B's, C's, and D's, I'd get 3 A's, 3 B's, and 3 C's, and 3 D's when I add them all up. Okay? So in this case, if I add up all the numbers, I'll get 5 P's, 5 Q's, 5 R's, 5 S's, 5 T's, and 5 U's. Okay? So this is a really, really fast way. And now, okay, I've got to add up all the numbers in the list they gave me. That's fine. If I got a calculator handy, it won't be a bit of a problem. But look at this. Now there's no emphasis placed on, what P is, what Q is, what R is exactly. They're all together. Okay? Now, whatever I'm going to get on this side, and I'll calculate it in just a second, will likely be a multiple of 5, because I believe they said they're all positive integers. Okay? In fact, I don't even think they needed to tell you they were positive integers. They're going to force to be positive integers so long as they started with them being positive integers. But let's add up these numbers. So 25 plus 30 plus 38 plus 41 plus 49 plus 52 plus 54 plus 63. I lost track. 54, 63, 68, 76, 79. It's really nice if you have one of those calculators that actually tells you the whole expression you've been plugging in the entire time. Plus 103, plus 117. That's 980. That is a multiple of 3. I'm pretty sure I added that up correctly. Although with it being the last question, I may wish to double check my work. So I'll write in this 90 here, and then just very quickly I'll go silent for a moment and double check my work. Thrilling, I know. Okay, I get 980 both times. All right. So the sum of all the numbers, regardless of which one is which, is 980. Now, if I divide 980 by 5, I'll get 196 over here. And that's P plus Q plus R plus S plus T plus U. Now, very quickly, keep your sort of eye on the goal here. We want R plus S, the middle numbers. Now, what could I very idly observe at the start? Well, P plus Q is 25 and T plus U is 117. So 25, 117 here. R and S, 196. So just bring them over to the other side. 196 minus 25 minus 117. And in fact, R plus S is not the 63 you might have immediately jumped to, being the middle numbers. It's actually 54. And that's pretty cool. Okay, so there we go, 54 right there. And yeah, so 54 is our answer here. So that's going to be B. We can bubble in B. Now, that finishes up the whole contest. That's great. I've liked this one. It is a very nice contest in general. And if you're looking for more multiple choice contests, I'll be doing the 2009 Pascal, which is the grade 9 level contest. So if you're interested in something a little more difficult, look for that coming up. But, you know, it's a video online. I think what I'm going to do now is I'm actually going to work out all the numbers P, Q, R, S, T, and U, or at least see if I can. I should be able to. I suspect I'll be able to. And if you want to, stay tuned, because I'm going to use, you know, sort of other ways to tackle problems like these. When you have all the possible sums written out as they've got, this is sort of what's called a symmetric sum, or, you know, sort of it's got a symmetric property in that every possibility is represented an equal number of times. It makes it very nice for adding things up. That nice little trick that we saw where we don't know what each individual sum is, so add them all up because we can figure out the total sum. And because every number is represented the same number of times, you get something very, very nice. It's a very nice little trick. If you haven't seen it before, it's a great one to learn. Now, let us continue on. I'm going to see if I can work out, for example, what P is. Now, how would I do that? Well, I know what P plus Q plus R plus S plus T plus U is. So, if I take that, and I could rearrange for P, couldn't I? I'm not entirely sure. I may have bitten off more than I could chew, and maybe there isn't a way to actually figure out what all these numbers are. But I'd like to think there is. Okay. Let's do a little more calculation. So, S plus U. What could that number be? I know it's got to be less than T plus U, but I don't think any other number is bigger than it. Only T plus U is bigger than it, so I think S plus U. Yeah, because I think the only other contender would be S plus T, and S plus T is obviously less than S plus U. R plus U is obviously less than S plus U. But R plus U is not necessarily less than S plus T, so there's sort of some ambiguity. Who's third, I don't think we can immediately tell. Similarly, P plus R should be the second smallest number. This might be another way you could approach the question if you didn't know how to add this all up. So P plus R should be 30. Again, ask yourself what numbers could possibly be smaller. It's got the smallest number and the third smallest number. The only way to make this smaller is to have the smallest and the second smallest. We already know that's 25. So P plus R should be 30. S plus U should be 103. And this should tell me, well, R minus Q, if I just subtract all of these, R minus Q should be 5. And T minus S should be 14. Okay. Now, what, if anything, can that help us out with? Well, let's see. That would mean that R is Q plus 5. And, let's say, no, Q is R minus 5, let's say. And T is S plus 14. Now what I'm going to do is I know what R plus S is, and in this statement here, the 196, I'm going to replace Q and T with another R and S. And then I think I can figure out what P plus U is. R minus 5, R, S, S plus 14, and U is 196. So cancel those out. You'll get an extra 9 over here, and then you'll get 2 R plus S's, and then a P plus a U, And that's 196, so we'll very quickly grab our calculator. 196 minus 9 is 187, minus 54 for the r plus s, minus another 54 for the other r plus s. P plus u should be 79. Now 79, I believe, was one of the numbers we actually have. Yeah, 79. So there's that one canceled out. I think I'll cancel the numbers that I do know, or in some way indicate them. So I know 25, I know 30, I know 103, I know 117, I know 79, and I know 54. Now this 79 here, there's only a few numbers bigger than it. 79 is p plus u. Now I'll tell you what, something I can guarantee you is bigger than p plus u is q plus u. Because q is bigger than p and the u is being held constant. And r plus u is bigger than that, s plus u is bigger than that, t plus u is bigger than that. But which numbers in our sum are bigger than 79? There's the 90, the 95, the 103, and the 117. These have to be those numbers. They have to be. It couldn't be something like r plus t or s plus t fitting somewhere in there, because we only have 4 numbers bigger than 79, and here are 4 numbers that I guarantee you are bigger than 79. So this blows everything wide open. Okay. Notice as well that some earlier things are confirmed. There's that difference of 14. There's that difference of 5. But quite importantly, now I can figure out, well, the difference of P and Q is 11. The difference of S and R is 103 minus 95, and that's going to be 8. Okay? Now, I know that P plus Q is 25, but I also know Q is 11 plus P. So this is 2P plus 11 is 25. Subtract 11 from both sides, 2P is 14. P is 7. And that tells me Q is 18. And then if I add 5, I get R, should be 23. If I add 8, I get S, which is 31. If I add 14, I get T, which is going to be 45. Fantastic. And if I subtract 7 from 79, I get U, which is going to be 72. And if I want to, I can just pick something at random. R plus S, well, that's actually 54. Q plus T, that's 18 plus 45. Is that an actual number in our list? 63. There you go. That's the one that gave us the one right in the middle. That's 63 right there. I know all of those ones. I know those ones. I know those ones. And we could do something like, well, so 38 is P plus S. So I know this one is P plus effect. How about I actually write out which ones are which? So P plus Q, P plus R, P plus S, T plus U, S plus U, Q, or R plus U, R plus U, Q plus U, P plus U, R plus S. I might have to, my handwriting's kind of big, but this was Q plus T. What else could we do? S plus T is going to be 76. R plus T is going to be 68. Okay, fantastic. Everything's sort of falling into place. P plus T is going to be 52. Okay. Q plus R is going to be 41. And we're missing one. Something like, so what could possibly, so we need 49. That's going to be Q plus S. There we go. Now I know what all the numbers are. Did I need to No. Did some of you probably try and do it that way? Yeah, and that's fine. It's a little more roundabout. And hopefully by watching the early parts of this video, you've learned sort of that special add them all up technique. And that way, you don't actually have to know which one is Q plus R or anything like that. Okay, so we had a few quick observations, a few quick deductions that, the smallest is the sum of the two smallest, the biggest is the sum of two biggest. We didn't fall into the trap that the middle should be the sum of the two middle numbers, because of course it isn't. And we were able to very quickly get our answer, and then, just for fun, which is always a nice thing to do, if you've done a math contest and you're all done, go back to the questions that you found intriguing. Generalize them, play around with them, look at bigger cases, look at special cases. Just some fun stuff to do to sort of sharpen your skills and to start thinking like sort of an active problem solver. Okay? But there we go. That finishes up our Gauss. Well, actually, we finished the Gauss a while ago in the video, but I thought that was a little fun diversion. And yes, I think I already said, but the Pascal will be up next. That's another multiple choice contest, and I will see you guys for that next week. Okay? So until then, have yourselves a wonderful day. Keep on doing math contests.